In the previous video, you have learned how to draw paths and shapes. Today you will learn how to animate views and apply transitions. When using SwiftUI, we can individually animate changes to views or to view state no matter where the effects are. SwiftUI handles all the complexity of these combined, overlapping, and interruptible animations for us. In this tutorial, we'll animate a view that contains a graph for tracking the hikes a user takes while using the Landmarks app. Using the animation modifier, you'll see just how easy it is to animate a view. If you want to follow along, download the starting project and the link is in the description below. At the end of this video, you'll learn how to add animations to individual views, how to animate the effects of state changes, how to customize transitions, and compose animations for complex effects. When using the animation modifier on a view, SwiftUI animates any changes to animatable properties of the view. A view's color, opacity, rotation, size, and other properties are all animatable. In HikeView.Swift, we're going to experiment with showing and hiding the graph. In order for us to view the result of each step, we'll use the live preview. The live preview is the play button in the canvas, which allows us to see a live preview of our work. Now we'll turn on animation for the button's rotation by adding the animation ease in out modifier. Since the rotation effect modifier is an animatable, it will now animate from a starting value to the next value. Next, we want to make the button appear 150% larger when the graph is visible. We do this by adding the scale effect modifier. Scale effect is also another animatable, which will animate when the scale value is changed. When opening the graph, we want to see a springy kind of animation. So what we need to do is just change the animation type from ease in out to spring. SwiftUI includes basic animations with predefined or custom easing, as well as spring and fluid animations. We can easily customize the speed of our animation, set a delay before an animation starts, or specify that an animation repeats. I'm going to add another animation modifier with a nil parameter before the scale effect line. By adding another animation and passing nil, the animatable before it will not animate even when its value has changed. Okay, before we move on to the next step, I'll make sure that I have removed both animation modifiers. Now that we have learned how to apply animations to individual views, it's time to add animations in places where you change your state's values. Here you will apply animations to all of the changes that occur when a user taps a button and toggles the Show Detail State property. Let's see what we have in the HikeView.Swift so far. Right now I'm going to show or hide the graph by tapping the Disclosure button. As you can see, the graph just appears and disappears. Now we're going to wrap the call to Show Detail with the With Animation function, and let's see what will happen. Now both of the views affected by the Show Detail property, the Disclosure button and the Hike Detail view, now have animated transitions. If ever you're curious about the toggle method, Boolean is just a struct that has the toggle method made for us, so we could conveniently toggle the Boolean value. Okay, let's see how we can slow down the animation and see how SwiftUI animations are interruptible. I'm going to pass a 4-second long basic animation to the With Animation function. We can pass the same kinds of animations to the With Animation function that we passed earlier to the animation modifier. Before we'll continue to the next section, I'm going to remove the slow animation from the with animation function call. By default, views transition on and off screen by fading in and out. You can customize this transition by using the Transition Modifier. We begin by adding a Transition Modifier with a slide transition to the conditionally visible hike view. Now you can see the graph appears and disappears by sliding in and out of sight. I'll be extracting the transition to be a static property of any transition. This keeps the code clean as we expand the custom transition. You can use the same dot notation for your custom transitions as you do with SwiftUI's included ones. As early as possible in the coding process, we need to clean up a bit. Every time when something works as intended, or if you've written unit tests, it is a good practice to refactor for a cleaner and easy to read code, or better, easy to work with code. I'm going to change the transition from sliding to a move transition, so that the graph slides in and out from the same side. If you look under the hood of any transitions, you'll see there are many extensions made for transitions. You may want to explore each one of them to see how they work. There are cases where we want the intro transition to be different from the exit transition. We'll use a different transition method for that. To provide different transitions when the view appears and disappears, we're going to use the asymmetric insertion removal modifier. First, I'm going to create an insertion constant. I'm going to set it with the move with trailing animation, then combine it with the opacity. For the removal animation, I'm going to use the scale transition and combine it with the opacity animation. And then we return an asymmetric modifier using the insertion and removal animations we just created earlier. Our graph switches between three different sets of data when clicking the buttons below the bars. In this section, we're going to use a composed animation to give the capsules that make up the graph a dynamic rippling transition. We begin by changing the default value for show detail to true and pin the hike view preview to the canvas. While we have that set, it makes it possible for us to see the graph in context while we work on the animation in another file. Now in the graph capsule.swift file, I'm going to add a new computed animation property and apply it to the capsule shape. Since we want the bars to hop, we will use the spring animation with a reduced damping fraction of 0.5. The lower the damping value used, the springy the animation is. Otherwise, the spring bounciness is reduced as the value is increased. I'm going to use 0 first as a damping value and then try it. Now I'm going to use 1 as the damping fraction and let's see what happens. I imagine damping as adding some foam or a thick layer of fabric on the floor. When you drop a golf ball, the ball will bounce lesser as more damping is added, in effect absorbs the energy, where the ball will have less energy to bounce back. Now I'm going to put it back to 0.5, which gives us the right amount of spring animation. Then we speed up the animation a bit to shorten the time each bar takes to move to its new position. We will use the speed modifier for that and set 2 as the speed value. The higher value used in the speed, the faster the animation. We'll also be adding a delay to each animation that's based on the capsule's position in the graph and multiply it with 0.03. Now let's test our animation by transitioning between graphs. Since we have used the index position, it provided us with a rippling effect when transitioning between graphs. Okay, we have made a lot of progress in this video, and I hope you have learned a lot. I just showed you how to add animations to individual views using the Animation Modifier, how to animate when a property value or state changes, and use the With Animation function, how to customize transitions using the Asymmetric transition, and compose animations for complex effects. In the next video, we will be learning how to build complex interfaces, and you may also want to check out my other videos on this channel. Since you don't want to miss any of my future videos, I want you to click the subscribe button and enable notifications by clicking the bell icon.